The surface area of any three-dimensional shape can be found by finding the individual areas of each surface and then adding up all of those areas. So we're going to start off with a rectangular prism, and a rectangular prism is just made up of 6 rectangles. And we know that the area of any rectangle is length times width. So if I just find the area of each rectangle and I add them up, then I will have my entire surface area. Now, with rectangular prisms, each side length has an opposite identical side. So let's start off with the base rectangle, which is a 2x3 rectangle. Now this surface can also be found up here at the top. So I'm going to say the area of base slash top is the length times the width, and then times 2 at the end because there are 2 of those surfaces. So the length is 3, the width is 2, and then I will double that. So 3 times 2 is 6. So each of the surfaces has an area of 6 meters squared, and when I double it, 12 meters squared. So that's for the top and bottom. Next, let's do the front and back. So my front rectangle is 5 by 3, and I have the exact same shape in the back of the rectangle, like so. So once again, we're going to have length times width times 2, but this time we have 3 times 5, a 3 by 5 rectangle. 3 times 5 is 15, so each of the surfaces is 15 meters squared, but when I double it, that is 30 meters squared. So far we have these areas. That's 4 of our surfaces so far. And the last one is going to be the right and left rectangle. So that would be the 2 by 5, which is also here. So the length times width times 2, 2 times 5 times 2. 2 times 5 is 10, so each of those surfaces is 10 meters squared, but when I double it, that is 20 meters squared for those 2 surfaces. Now we can add everything together. So surface area is the 12 meters squared from the top and bottom, the 30 from the front and back, and the 20 from the right and left, which leaves us with a surface area of 62 meters squared for this rectangular prism. Now this is kind of the, I guess, visual or logical way of doing it. There is also a formula for surface area, which I just think is a little bit too wordy. It is 2 times length width, length height, width height. Something like this, which gives the same message as what we did here. Now for a triangular prism, I definitely don't like the formula just because there's so many surfaces involved. So with a triangular prism, we have 2 triangles right over here, the front and then the back triangle. And then we have 3 different rectangles around the surface. Okay, so let's start off with the area of a triangle. So area, triangles. The area of a triangle is base times height divided by 2, but I have 2 of them. So if I look at the triangle here, the base is 6 and the height is 4. So 6 times 4 divided by 2, and then times 2 at the end. So 6 times 4, 24 divided by 2 is 12. So that means each triangle is 12 centimeters squared, but I have 2 of them. So that's 24 centimeters squared in total for the front and the back triangles. I think that's the most difficult one, but now we just have 3 triangles to deal with. So the first one, or sorry, 3 rectangles. The first one is the base. The base is 6 by the 12, which is along the top. So area of base is 6 times 12, which is 72 centimeters squared. And there was only one of those. So we have this and we have this so far. To finish this off, we have 2 rectangles that are identical on the right and left. So that's going to be, it comes from the 12 by 5, and there's the same thing on the right side as well. So imagine a Toblerone bar or a tent. Those 2 top pieces in this case are the same, 5 by 12. So 5 times 12, and then we will double it. 5 times 12 is 60, so that just means one of the surfaces is 60, and when I double it, that's 120 centimeters squared. And now that I've circled the main sides, I'm just going to add them up. So here are the 2 triangles, the base rectangle, and the 2 side rectangles. And when we add those up, we get 216 centimeters squared. So there we are, very visual. Trying to imagine that shape in your hands so that you can kind of manipulate it is helpful, or even actually having, let's say, a Toblerone bar beside you so you can see the surfaces a little more clearly. Now, the last prism we have is a cylinder. This one does have a nice clean formula, so I tend to use it, but I do want to explain where it comes from. So the formula is 2 pi r squared plus 2 pi r h. 2 pi r squared comes from the 2 circles. You know that the area of a circle is pi r squared, but we have the top circle, and then we have the base circle. So I have 2 of those, and that's why we have 2 pi r squared. 2 pi r h comes from this lateral surface. I want you to imagine a water bottle and the label around it. When you peel that label off, it forms a rectangle. You're left with a rectangular strip. So you're multiplying to find that area, the length and the height. So h is the height, or one of the dimensions of that rectangle, and 2 pi r is that bottom length, which comes from the circumference around the circle, and circumference is 2 pi r. So if I unravel it, the perimeter around the circle is the length, and then the height of the cylinder is the width of that rectangle. And when you multiply them, that's what you're left with. So in this case, our radius is 6, our height is 10, and we just have to put it into our formula. So 2 pi 6 squared for r squared plus 2 pi, instead of r, we'll put 6, instead of h, we'll put 10. You can do this all at once in your calculator. We can also do this in steps. So I'm going to do 2 times pi times 6 squared all at once. If you want, you can also do 6 squared to get 36 and then do the multiplication. Now I do want to make sure you use the pi button, not 3.14. And let's just round to 1 decimal. So 226.2. And then 2 times pi times 6 times 10. That gives us 377.0. And then we can add those up together. Now, if you don't use the pi button, you use 3.14, your answer might be slightly different. Using the pi button is just definitely more accurate. So there's our surface area for a cylinder. So the 2 circles, and then that rectangular lateral surface. And that's it for surface area of prisms. As long as you know, for the rectangular prism and the triangular prism, if you know the area of a triangle and the area of a rectangle, you have everything you need. For the cylinder, we have this quick formula.